let's try this last one that we have here. We have e to the 2x minus 2 minus 1 divided by x minus 1. Zoom, standard. What does it look like? Aha! Did you catch it? My mistake? Let's go back. What did I miss here? What did I miss? What did I miss? What? Ta-dum. Okay, good. Parentheses. Good job. Okay, so let me insert parentheses here on the numerator. Now make sure you press insert so that you don't erase the other stuff that you had. So insert parentheses, insert, actually that one I didn't have to. But this produces a much different picture than the other one. So you got to be careful with that. Make sure you put your parentheses. Okay, so let's go back. Let's take a look. Where are we going? We're going to x as x approaches 0. So let's zoom in at 0. And it looks like, let's trace here, as we approach 0, looks like we're going to some funny number here. So let's zoom in a little bit more. Okay, so if we trace it, what do you notice here at x equals 0? Well, you might notice that it's actually defined at x equals 0. And you'll also notice the function is continuous, so this is simply equal to e to the 2 times 0 minus 2 minus 1 all over 0 minus 1, which is approximately equal to 0.8647. So in this case, it's continuous, so we can simply plug in 0 and we get the answer. Okay, so for the next two problems, we have a piecewise function here, and this one we're going to have to convert it into a piecewise function so that we could see what the limit is. But let's do this one first. So the idea is that we want to find the limit as x approaches a from the left and from the right. So here for this one, a is equal to 3. So what we're looking for is the limit as x approaches 3 from the left and the limit as x approaches 3 from the right. Okay, now we're going to do this algebraically first. So let's write this down here on this piece of paper. So we have f of x is equal to x squared minus 2 from 0 to 3, 2 when x is equal to 3, and 2x plus 1 when x is greater than 3. Okay, so if I want to find the limit as x approaches 3 from the left, well, since I'm approaching from the left, what that means is that I'm looking at numbers that are less than 3. So if I take a look at these, this function is defined to be x squared minus 2 from 0 to 3, 2 when x is equal to 3, and then 2x plus 1 when x is greater than 3. So since these are numbers that are less than 3, then which one of these three would I use? Exactly. This one. So this means that I'm going to plug 3 into that first one. And that's going to give me 7. Okay, now let's do the same thing from the right. The limit as x approaches 3 from the right. Let's do blue. Okay, so if I'm coming in from the right, well, that means that these numbers are greater than 3, which would mean that I'm going to use this one. So I'll plug 3 into there, so I have 2 times 3 plus 1, which is 7. So this isn't asked in the question, but let's just state it. If I want to know what the limit as x approaches 3 of the function is, remember this means you want to look at both sides. So since from both the left and the right it equals to 7, then that means the limit exists. And it equals to 7. Okay, now that's all fine and dandy. But let's take a look at the picture. Let's see what it looks like. Let's do the graph. From 0 to 3, not including 0 or 3, the function is x squared minus 2. So this is a parabola that's shifted down by 2. So at 0, this guy equals negative 2. At 1, this guy equals negative 1, and then right here somewhere, this is going to cross. So we have this circle, and you'll notice that at 3, if I plug in 3 here to see where it's going to be at x equals 3, we would get 7. But not including the value at 3. So at 3 it's going to equal 7, so I'm going to put a open circle there. And I'm just going to kind of continue on here. Well, that was pretty good. Okay, so that's what that first part looks like. Now we have this one. When x is equal to 3, the function is equal to just simply the number 2. So at x equals 3, the function is equal to 2. So that means we would have a solid circle there. Okay. And then after that, for x greater than 3, it equals to the line 2x plus 1. So I'm just going to plug in a couple of values. I know that at 3, this line is 7. So here. And then, but it's not including 3, so that's why we would have an open circle again. And if I plug in, let's say 4, I would get 4 times 2 is 8, plus 1 is 9. So when x is equal to 4, this guy is equal to 9. So this is the straight line. It looks like that. Okay, so question. Is the function continuous at 3? What do you think? Dun, 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 dun. Is it continuous right here at 3? What do you say? That is correct. Nope, it is not. Because the limit as you approach 3, although it exists and it equals 7, the value of the function at 3 is equal to 2, so those are different. So that means that it is not continuous. Okay, now let's go on to the next function, this guy right here. And so we're going to find the limit as x approaches 4 from the left, and the limit as x approaches 4 from the right. Now, although this doesn't look like a piecewise function, in reality, it can be described as a piecewise function. Because this guy, so let's convert remember that the absolute value of x can be described as a piecewise function. Remember that what the absolute value does is it turns every number that you plug into here into a positive number. So what that means is that, let's say x is greater than 0, then that means that this guy right here would equal to x. So for example, if I plug in positive 4, that equals to just 4 as well. So that's exactly the same thing. Now, if x is less than 0, however, this absolute value is going to turn it into a positive number. Well, how do you turn a negative number into a positive number without the absolute value? Well, what you can do is simply multiply it by a negative sign. So these two are basically, what you're saying is that they're equivalent. Okay. So, if this doesn't make 100% sense, try plugging some numbers into this one and plug it into the piecewise function and see if you get the same thing. Now, you might be wondering, what about at 0? Well, we can put that it equals to this guy when x is greater than or equal to 0. Because it's actually the same in both, so it doesn't really matter. Because when you plug in 0 into this guy or this guy, you get 0 each time. Okay, now let's talk about this one, though. Let's try to turn this function into a piecewise function. So let's first of all write down what absolute value of x minus 4 is. Well, the idea is the same. The idea is that when this guy, this whole inside, when x minus 4 is greater than 0, when this guy is positive, this guy is going to equal to x minus 4. So what this tells you, if you bring the 4 over to the other side, is that if x is greater than 4, that means this guy is going to be positive, which means these two are equal. So that one's pretty easy. But now what happens if x minus 4 is less than 0? Well, if x minus 4 is less than 0, that means this guy would be negative, but this is telling you that it's always going to be positive. So if this is always going to be negative, then you need to multiply the entire thing by a negative sign. So this would be negative x minus 4 when x is less than 4. Okay, so if that's what this guy is, then that means that absolute value of x minus 4 divided by x minus 4 is equal to so let's do it one by one. Here we have x minus 4 when x is greater than 4. So this would be x minus 4 over x minus 4 when x is greater than 4. And this would be when x is less than 4. This would be negative x minus 4 over x minus 4. Well, lo and behold, what this means is that this guy is actually on top. This is equal to 1 when x is greater than 4. And negative 1 when x is less than 4. So this is what this guy up here simplifies to, which is pretty crazy if you think about it. So now finding the limits is really easy, because if you wanted to know the limit as x approaches 4 from the left of our function, well, you look at numbers that are on the left less than 4. So this is equal to negative 1. And if you want to know the limit as x approaches 4 from the right, that means you're looking at numbers that are greater than 4, which means you would use this one, so this is equal to positive 1. Okay, now if we try to graph this guy, what this guy looks like, this guy is, we said earlier, is 1 when x is greater than 4, and negative 1 when x is less than 4. So now notice that x can't equal 4 in this case, because 4 would make this function undefined. So that's why we don't have it equaling 4 in either of these. Okay, so when x is greater than 4, it equals to 1. So it equals to 1. When x is less than 4, it equals to negative 1, which is down here somewhere. And so that's what the function looks like. If you come in from the left, you get to negative 1. If you come in from the right, you get positive 1. And that's it.